CNC machines are mesmerizing pieces of kit to watch in action. But how exactly do they work? CNC, or computer numerical control, is a process of using a computer to control, automate, and monitor the movements of a machine to manufacture parts from stock materials, like a block of steel. You can liken it to a 3D printer that cuts away material to create an object, rather than building up material to form it. Not a perfect analogy, but we think you get the idea. They can be used in many forms of traditional manufacturing machines, like milling machines, lathes, routers, welders, grinders, laser cutters, water jet cutters, sheet metal makers, slumping machines, and many other types of machines. CNC machining was developed in part to overcome the limitations of manual machining by live operators who need to prompt and guide the machining tools via levers, buttons, and wheels. They are faster, more precise, and more accurate than using highly skilled human machinists, and they are nothing new. Some of the first CNC machines were developed as early as the 1940s and 1950s. These early machines took instructions from punch cards to provide the instructions required to automate the machine. In industrial applications, CNC devices are usually onboard dedicated controllers. But for hobbyists, the CNC controller is generally an external PC or laptop, but not always. In either case, the CNC controller basically commands a series of motors and drive components to move and control the machine's axes, to execute a series of pre-programmed movements, to cut out and form something in 3D. Such systems can be incredibly sophisticated pieces of kit that constantly monitor and adjust a cutter's speed and position over time. Desktop CNC machines tend to be more compact, lightweight, less precise, slower, and less expensive than their industrial counterparts. But they usually excel at machining softer materials like plastic, foam, wax, etc. All well and good, but how do they work? In essence, a CNC machine is a computer-controlled carving machine that can precisely control the cutting edge through a series of axes to create a 3D object or part. You will often hear them referred to as 2.5-axis, 3-axis, or 5-axis, which simply refer to the degree of flexibility that the CNC can manipulate the stock material and its cutting tools. The higher the number, the more directions the machine can work in, with 5 axes offering the greatest amount of flexibility. Instructions are provided by computer code, like G-code, that tells the machine how to move the cutting edge and stock material, what feed rate and spindle speed to use, which cutting tools should be used, coolant flow, etc. Any mounted cutter will then carve through a specific material and create an intended shape. Most CNC machines can also automatically swap between cutting tools on command too. CNC machines tend to come in 3 main forms. The first uses basic drill bits that spins at high speed, makes contact with the stock material, and removes it where needed. The next use is lathes. These work in reverse to drills by spinning the stock material and cutting off material against a stationary drill bit or cutter. The third, and by far the most common, are milling machines. These use rotary cutting tools to remove material from a stock piece. They are the most precise and tend to be the go-to CNC machine for creating high-precision engineering pieces. Any removed material, usually called chip, is also removed and can usually be recycled later. Usually the CNC machine will be programmed by a programmer using CAD or CAM software to calculate the 2D and 3D paths required for any tool to follow to carve out the intended model. These software can also be used to design and build the model of the part in question to be CNC machined. Once a programmer has completed their programming work, the program is fed into a post-processor that turns the CAM program into another form of code that the CNC machine can understand. This code is then uploaded into a CNC machine, along with all the cutting tools needed, raw materials to be used, and work holding needed for the raw material. A machinist will then set the CNC machine into its automatic mode to start the program and make the piece in question. CNC machining is awesome, but it is not without its limitations. But the benefits of these machines far outstrips their shortfalls. For this reason, CNC machining will continue to dominate the automated manufacturing scene for some time to come.